So this is the last section for chapter 3. So we've talked about, let's put that away. We've talked about in chapter 3 parallel, perpendicular, skew lines, right? Being able to recognize them. We talked about what happens when we have parallel lines with a transversal that cuts through it. We get corresponding angles that are congruent. We get alternate interior angles that are congruent. We get alternate exterior angles that are congruent. And we get consecutive interior angles that are supplementary. Right? Then we got into what you took your quiz on today, the slopes of parallel and perpendicular lines, and then writing equations of parallel and perpendicular lines. So now we're going to talk about theorems that incorporate parallel and perpendicular lines. All right, so our first one states that if you have two lines, so if two lines intersect to form a linear pair of congruent angles, comma, then the lines are perpendicular. Makes sense, right? These are kind of like, well, yeah, that does make sense. So if I have a line and another line, and it creates two angles, and angle 1 is congruent to angle 2, well, if they make a linear pair, that means what? They add up to 180. And if they're the same angles, what degrees do they have to be? 90. They both have to be 90, right? So that means that these two lines intersect at a 90-degree angle, which means that they are perpendicular, right? So that's what this diagram is saying. So if we had line H and line G, this is saying if these two angles, which are a linear pair, they make a straight line, so that means they add up to 180, they're supplementary. If these are congruent, then that means they both need to be 90-degree angles, which means that we have to have perpendicular lines.
Wait,
easy enough?
What does linear pair mean in that?
Linear pair is anytime you have two angles that are adjacent and make a straight line. So that would be a linear pair. This would be a linear pair. This would be a linear pair. So angle 1 and angle 2 are linear pairs.
One wouldn't be perpendicular.
Correct.
Of those.
So when my linear pairs, so when those two angles become the same, they become right angles, which means that they would be perpendicular.
What does it say that on that?
So when the linear pair of congruent angles. So when they have to be congruent, which means they both have to be 90 degrees.
I was thinking congruent lines.
Yeah, no. We're not going to have congruent lines. Congruent angles. Okay? It's good to talk through it. All right, next one. Theorem 3.9. If two lines are perpendicular, then they intersect to form 4 right angles. Well, that one we already kind of knew.
I keep thinking, even though these are theorems, I thought they are sections in the book. I mean, it's so. Don't get me wrong, I understand that these are theorems,
Yes.
but why do I keep on thinking that they may be sections in the book?
Well, some theorems have a lot going on in them. This one, not so much. This one makes sense. If you got perpendicular lines, if one of your angles is a right angle, the other one has to be a right angle because they make a linear pair. Your vertical angles are congruent, so that makes that a right angle. That makes that a right angle. So you got 4 right angles going on, right? We already knew that, didn't we? If I gave you 2 perpendicular lines, I said, okay, we got perpendicular lines. What's the measure of angle 1, 2, and 3? You'd say 90, 90, 90, right?
Yeah.
You knew that before getting this theorem. All right, so this is the type of stuff you're going to be seeing for your homework. It says in the diagram, line AB is perpendicular to line BC. What can you conclude about angle 1 and angle 2? So what are some conclusions we can make?
They're supplementary and congruent.
Okay, so angle 1 is congruent to angle 2. Okay, they are a linear pair. We could write that down. I'm not going to because that doesn't really tell us anything about perpendicular. So if they're congruent, what can we conclude about their degrees, Scott? Right. So the measure of angle 1 is 90 degrees. The measure of angle 2 is equal to 90 degrees.
So they're complementary.
No, complementary means they add up to 180. They would be or up to 90.
90.
Supplementary would be in this
180.
case. Right. Okay. Easy enough. All right, theorem number 10. If two sides of two adjacent acute angles are perpendicular, then the angles are complementary.
Yeah.
So if we think about this, we have two sides of two adjacent angles. So adjacent means that they are touching each other. So then they have to be acute, so that means they're less than 90. So if these make a right angle, what would be true about angle 1 and angle 2?
45.
Well, not necessarily. We're not saying they're congruent, but they would be two angles that add up to 90, which means that they would be complementary. We don't necessarily assume that they're going to be equal to each other. Okay, so flip on to the back once you have that. So what can we conclude about the following? So given the measure of angle ABC, well, where's ABC? ABC is right there.
More like CBA.
Yeah, whichever way you read it. Or ABD. So if those are congruent, what can I assume about them? If these two angles are congruent, what can I assume about the lines? What was the first theorem that we said?
3.8.
They're perpendicular.
They're perpendicular, good. So if I know that this angle here is congruent to this angle here, then I know that the lines are perpendicular. So what has to be true about 3 and 4? They're complementary. So angle 3 and angle 4 are complementary.
Or just put a complement in for short, for an abbreviation.
Sure. So far pretty easy?
Yeah.
I think so.
No.
All right, 2 more theorems. Theorem 11. Oh, here's that nasty transversal.
Oh, great.
If a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other. So let's wrap our brains around this one. So we've got a transversal that's perpendicular two parallel lines. If this angle is 90 degrees, we know this angle is 90, this angle is 90, this angle is 90. Why would this angle here be 90 degrees?
Because those two are parallel.
The two lines are congruent.
Two lines are not congruent, the two lines are parallel. What type of angles are these?
Consecutive.
No, they're
Corresponding.
So if
Corresponding.
lines are parallel, then corresponding angles are congruent, right? So that makes this 90 degrees, which makes that 90 degrees, that 90 degrees, that 90 degrees, which makes J also perpendicular to K, right?
Okay.
All right, so now we can look at that differently. So if we have, so in a plane, if two lines are perpendicular to the same line, then they are parallel to each other. So this is another way to prove parallel lines.
Yeah.
So notice line M is parallel to, or is perpendicular to line P. Line N is perpendicular to line P. So since they're perpendicular to the same line, I can conclude that they are going to be parallel to each other. So M would be parallel to N. The proof behind it would be if corresponding angles are congruent, then lines are parallel, right?
Yeah.
Converse of it. So if these are both 90 degrees, then they have to be parallel to each other. All right, so let's figure out which are the parallel lines in this next example.
So the proof would be.
Are you joking?
No, I'm not joking.
Brent, does the teacher lie?
Sometimes.
When they say this is going to be easy.
All right, let's focus on line S. Line S is perpendicular to what lines? P and
Q.
Q.
So that means T is parallel to
U.
Now let's look at T. Is T perpendicular to anything?
No.
Yeah.
Yeah.
T
It's-
and Q.
Well, it's not. We don't know for sure P. It's not telling us for sure P. It's only
Well-
telling us for sure Q.
Well, if you go back to the
So is S
311.
and T?
Parallel.
Is S and T? Well, we're not given parallel lines. 311. I needed parallel lines.
I
So
mean,
S and
312.
T, are they perpendicular to the same line?
Yeah.
Yeah.
Which
Yes.
same line?
The bottom one.
The
Q.
bottom one, Q. So since they're perpendicular to the same line,
That
that's
is
enough
parallel.
evidence to say that S is parallel to T.
Do we know P and Q are parallel?
Well, let's look at that. Is U perpendicular with anything?
No.
No, so throw U out the window. That's not going to be an answer. So now let's focus on P and Q. Is P and Q perpendicular to U? No. Is P and Q both perpendicular to T?
Yeah.
No.
No. Is P and Q both perpendicular to S?
Yes.
Yeah, so can I say P and Q are parallel?
Yeah.
Yeah, so
Yes.
P is parallel to Q. All right, so does that work?
Yes.
All right, so now we're going to kind of flip the script a little bit. This is kind of thrown in from left field. We talk about the distance between 2 points. Do you guys remember your good old distance formula?
Yeah.
Yes.
What is the
So
distance
do we
formula?
actually not do anything with you?
No, because U is not perpendicular with anything. So U,
AB equals Y.
do you remember it?
Y2.
Square root of
X2
x2 minus x1 squared plus.
What? I thought it was my. Yeah, never mind. Never mind.
There's your minus. All right, so in this case, we need to find the distance from point A to line C. And to find distance, you need to find the perpendicular length from A to C. So don't write this, just watch. If I drew a line straight down from A to line C, would that be the shortest distance between point A and line C?
Yeah.
No.
Right here? No, that would not be the shortest distance, right? What about if I went horizontally? Is that the shortest distance?
No.
No. My
No.
shortest distance really is where?
Straight right there.
Perpendicular,
You
right?
don't know that's perpendicular.
Well, we could make it perpendicular. What's my slope here? My slope is going down 1 over 1.
Yeah.
So what's the reciprocal of -1?
Up, positive.
Positive.
Right, so my perpendicular slope would be +1. Does this line have a +1 slope?
Yeah.
Yes. Okay, so how do I find the length of that line? What are the 2 points on the line?
C and
A.
Well, C is the name of the line. It's this point. What are the coordinates of this point right here?
-1,
-1,
0.
0, and the points here
0.
is,
Oh, up there.
yep,
1, 2.
1, 2.
Yeah.
Okay. So using those points in my distance formula, so if it helps, x1, y1, x2, y2. So what am I going to subtract?
Minus, I mean,
1 minus
Negative
-1, which goes to a +1. And then y2, which is 2 minus 0. So 1 plus 1 is
2.
2 squared plus 2 squared. So 4 plus 4, which is
8.
8. For now, we're just going to round it to the nearest tenth. So square root of 8 is about 2.8 units would be the distance that point is from A. Okay, so I think you have 2 problems on your homework where you're going to have to find the distance. So to find the distance from something to another, you have to find the perpendicular line that connects them. I made my line to, so I think on the homework they give you like 2 options of points. They give you this option and this option. You just need to figure out which one gets you the perpendicular line.
Okay.
The top one, right? So those are the 2 points you're going to use, not these 2 points. All right, that is it.